6.5, prove triangles similar by SSS and SAS. So if you think back to chapter 4 with congruent, what do you think SSS stands for? It is once again going to be side, side, side. And SAS, once again, will be side, angle, side. Now the difference is we're proving them similar. We're not going to prove them congruent. So there is a difference, and you'll see a difference in the work. And the other thing you're going to notice with what work is necessary for these, you're not going to see these in proof format very much. We're not going to see a 2-column proof or a paragraph proof. We're going to show some work, but I'm not going to have you put them into a proof format. Okay, so the first theorem says side, 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 similarity theorem. If you can prove corresponding side lengths of two triangles are proportional, then the triangles will be similar. So again, we're not proving sides congruent or proving them proportional, which means like side AB over RS equals BC over ST equals CA over TR. So if all three sets of sides are in the same exact proportion, and it is important that we get all three, okay, you can't do two sets and then say it, you have to do all three, then you can prove your triangle similar. Okay, so let's practice this a little bit. We have some different sets of triangles, and you'll notice I wrote this little margin note. You must check all three pairs of sides. You can't do two, you've got to do all three. Okay, so as we do these, I stress like you find a pattern to how you do this because you don't know if they're similar or not. So what I usually start with, and one thing that's important as we start, the first one is I need to narrow it down. I'm going to do these two triangles first, ABC and DEF, and you don't know exactly which side should correspond. So what I would suggest you do is go like shortest sides first. So on ABC, I see the shortest side is 8, and on DEF, I see the shortest side is 4. Okay, so I set up my ratio. I always reduce to lowest terms, and there's my first one. So now I go to my second one for the longest sides. Again, choose kind of a category so you know which two you're looking for. So on the longest sides on ABC, I see is 12. The longest side on DEF is 8. I can divide both by 4, and I get 3 over 2. Now, to be honest, we can stop right there because I already see I'm not the same, so I know they're not similar. I'll check the remaining sides just to see. So my middle side would be 9 on ABC. My middle side would be 6 on DEF, and I divide by 3, and I get 3 over 2. So I had 2 match, but not all 3, and I have to have all 3. So all the ratios are not equal, so ABC and DEF are not similar, okay? So now let's try the next two. This time they want me to try ABC with GHJ. So I'm trying ABC with GHJ, this second one over here. So leaving the middle one alone and just looking at the first two. So once again, I'm going to go shortest sides. So on ABC, my shortest side was 8. And on GHJ, my shortest side is 16. I can divide both by 8, and I get 1 over 2. I go to CA over there for my longest side on ABC is 12. My longest side on GHJ is 24. Divide both by 12 to reduce it, and I get 1 over 2. So far, so good. I'm going to check my remaining sides. So the middle side over on ABC was 9. The middle side on GHJ is 18. I divide by my 9 on both, and I get 1 over 2. So all my ratios are equal, so that means that my triangles are similar. Now remember, when we write this similarity statement, that's what this is called when we have the name of my triangles, and we say that they are equal, or I'm sorry, not equal, similar. So important we get the order, okay? So if I'm going to name my first one ABC, okay, ABC, that's how I'm going around. I started with my short side, my middle side, then my long side, so ABC. So when I go to my next triangle, I need to go and start at my short side, then my middle side, and then my longer side. So the order there has to be GHJ. They do not always go in alphabetical order, and we have to be careful on that order. All right, so the first one, side beside side, all three sets of sides have to be in the same scale or scale factor. Moving on to page 2. It says find the value of x that will make these triangles similar, okay? Well, to make these triangles similar, we need sides that match as far as they have the same ratio or they're in the same proportion. So we look at these names, ABC and DEF, okay? So I see that I have side BC over here is 4, and I have side AB over here is x minus 3. Okay, I'm looking at the work they're starting me with. So I need to figure out BC, that's the last two, has to go with EF. So EF over here is 10. I'm going to put that on the bottom. Okay, and remember, my names give me this clue. So AB is the first two letters. It needs to go with DE, the first two letters. And DE over here in this picture is 20. So there's my proportion. Notice on the top, I have sides from the left triangle. On the bottom, I have sides from the right triangle. We need to stay organized. Once we have our proportion set up, now we're going to cross multiply. So 4 times 20 is 80. Those are my extremes. 10 times, and this is super important, this parenthesis x minus 3. Those are my means. Distribute my 10. I get 10x minus 30 when I distribute the 10. Add 30 to the other side. I get 110 equals 10x. Now when I divide by 10, I get x equals 11. Am I done? I am, because they did ask me for the value of x. But I can do a quick check to make sure they make sense. So if I think of 11 minus 3, I get 8, right? So is 4 over 10 equal to 8 over 20? The easiest way is to cross multiply. I get 80 and 80. So I would say yes, definitely works. All right, they said, well, wait a minute. DF up there has 2x plus 3. If I do 2 times 11 plus 3, I get 22 plus 3 is 25. And if I want to, so if I call this side 25, I can match it with that 10 over there. So 10 over 25 can go with my 4 over 10. And again, I can cross multiply and I get 100 equals 100. So I would say we're good either way on all of them. So x equals 11, then my triangles are similar. If it was any other number, my triangles wouldn't be similar. All right, let's move down here. Some more practice, same idea. We're not changing the idea yet. So it says, which of the 3 triangles are similar? Okay, so once again, remember, we're going to compare like shortest, longest, remaining. I'm going to start out with triangle ABC and triangle PQR. And I don't know if I'm naming those in order, but I'm going to just try them. Okay, so on my shortest side of ABC, I see 38. Shortest side of PQR, I see 30. I can divide both by 2, and I get 19 over 15. Okay, I'm going to the longest sides. The longest side on ABC is 54. The longest side on PQR is 45. I think I can divide both by 9. I'm going to get 6 over 5. I can tell already, are these two going to be similar? Definitely not. Okay, so I'm going to say not similar. I definitely need some more room. I'm going to change colors as well. Okay, so now I'm going to go with triangle ABC, and I'm going to go with that bottom one, XYZ. All right, shortest side. ABC shortest side is 38. XYZ shortest side is 18. I can divide both by 2, and I get 19 over 9. So far, so good. Okay, let's go to the longest side. Longest side on ABC is 54. Longest side on XYZ is 27. I can divide both by 27, and I get 2 over 1. Is there any way these are going to be equal? No. So these two are not similar. Okay, ABC is not a good triangle for me. So let's try, we have one more set to try. Let's try triangle PQR with triangle XYZ. All right, shortest side of PQR is 30. Shortest side of XYZ is 18. I can divide both by 6, and I get 5 over 3. Okay, let's go with the longest sides. Longest side on PQR is 45. Longest side on XYZ is 27. Divide them both by 9, and I get 5 over 3. We're on to something. Let's go for the remaining or the middle side. On PQR, that would be 35. And on XYZ, that would be 21. Divide them both by 7, and I get 5/3. I like it. All of them have the same one, so that means that they are similar. So which of those 3 triangles are similar? Okay, I'm going to start and name my first one. I get to choose the order of the first one, PQR. And now I need to make sure I name them in here. So if I started P, then Q, then R, I went across the longest and then the shortest. Okay, so I need to start somewhere where I can go across the longest and then the shortest. The longest is 27, 18, so I need to go this way. Cross the longest and then the shortest. Yeah, notice my order here is going to be triangle ZXY. Okay. All right. For number 2, I think we're still back using these pictures. It says, suppose AB is not given in ABC. Okay, so go up to AB here, and we're going to say it's not given. In fact, we're going to cross it off and make it a great big X. Okay, what length for AB would make it so ABC is similar to QRP? So we want these two to be similar. Okay, so I need to make sure I go ABC on top, QRP on the bottom, as far as values I find. Okay. And they kind of gave me an order here, so I'm going to use this order, A, B, C, or AB to QR. So AB we don't know is X. QR down here was 30. All right, I need one more set. I'm going to go with the next one, BC. So BC was 42, and RP down here was 35. So I'm setting up my proportion and solving to find a good value for that, okay? Cross multiply, I get 35x equals, 42 times 30. Calculator will be handy for that. 1,260. Now I divide by 35 to find my x. And I do get 36. So if AB is 36, instead of that 38 it started out with, I would have been proportional, okay? And just for the record, you could have used side CA and PQ as well. You didn't have to use those two. All right, moving on to page 3. This is our second theorem for the chapter, or for this section, I should say. We had one earlier this chapter. This is the side angle side similarity. It says if an angle of one triangle is congruent to an angle of a second, and then the lengths of the sides, including those angles, are proportional again. We can't go congruent. These are always proportional. Then the 2 triangles will be similar. So this is saying I need one set of angles congruent, and then I can just do 2 sets of sides. But it's so important that its side angle side must be in order with no gap. So the angle must be, and this is so important, must be between the sides. Okay? If you have a different angle and it's not between the sides, it doesn't do you any good. Okay? All right. I keep always saying every year when I do this problem, I'm like, I'm going to redo these numbers because this one is just kind of annoying to me, but we're going to use it, okay? And hopefully we'll get the point across. Okay. You are drawing a design for a bird feeder. Can you construct the top so it is similar to the bottom using the angle measure and the length shown? Okay. So we're looking for some similar, or I should say proportional sides, congruent angles, something like that. In all this stuff, can you see this 87-degree angle right there and that 87-degree angle there? If you can see that, we know that the measure of angle B on top and the measure of angle E on the bottom both are equal to 87. So that means we have one set of congruent angles. So our angles are good, okay? Now we're going to check some sides. I have AB, I'm hoping matches DE there on the bottom, right beneath it, okay? And I'm hoping that EF on the bottom goes to BC on top. So we're going to plug in the values and see are they proportional. So AB is 32, DE is 20. BC is 32, EF is 20. Okay, now I'm going to be honest. You don't have to know anything about math to know that 32 over 20 equals 32 over 20. So that doesn't really make you do any math. But if your numbers were not the same, you can either cross multiply to see if they equal the same product, or you can reduce them both down to the same fraction, okay? So what this is telling us is that the length of the sides that are including or around angle B and angle A are proportional because they are equal. The proportions are equal. So by side angle side, my triangles are similar, okay? Probably, like I said, not the best example since it didn't make us do the math to prove much. And the same thing with number 3. Once again, it's a good problem, but again, it doesn't make us do a lot here. In example 3, suppose you use equilateral triangles on top and bottom. So if you think about it, I have equilateral triangle on top, equilateral triangle on the bottom, okay? What's special about an equilateral triangle? All the sides are equal, right? And all the angles are equal. What are all the angles in an equilateral triangle? 60 degrees, okay? So do we have congruent angles? Yes, it wouldn't really matter. So if I call this one ABC and I call this one DEF, similar to up top, then obviously, again, I can say angle B is congruent to angle E. To be honest, I could say any set of angles are congruent, but we definitely have some angles. Are my sides proportional? Okay, this sounds funny, but if I do AB, double mark, over DE, single mark, equals CBC, double mark, over EF, single mark. I'm using symbols. Are those proportions or ratios congruent? Yeah, because they're the same thing. So definitely here again, yes, by side, angle, side. All right, last set of notes, or last page of notes for this set of notes. How's that sound? Okay, 3 ways we can prove triangles similar, okay? 6.4, we learned about the angle-angle similarity, okay? And in that regard, all we had to prove is 2 angles congruent, and then my triangles are similar. I have side, side, side that I learned today. That means that I need to prove 3 sets of sides, right? The exact same ratio. Or I can kind of mix them, and I can have side, angle, side, where I have 2 sets of sides, right, proportional or in the same ratio, and the angles between them, okay? So those are my 3 ways. Okay, so which one was easiest? Definitely angle, angle. 2 sets of angles congruent. Okay, so for my choice, I'm always going to look first, can I prove some angles congruent? Because if I can, it's going to shortcut my work. If I can't, then I start working on, okay, if I can only do 1 set of angles, can I do side, angle, side? I'm probably going to leave side, side, side for last because it's just not my favorite. It takes more time. So again, you choose, but you have to be ready to go through each set and try to figure it out. So on number 4, I have 2 triangles, and they say, do you think these triangles are similar? So I'm going to look first for angles. Are there any angles I can prove congruent? You're right, with that little X right there, I get some vertical angles, those angles that are straight across from each other. So I do have 1 set of angles. So PRQ and TRS are congruent, so I have 1 set of angles. Okay, sides. Okay, shorter side to shorter side. By the way, I'm going top and bottom so I can organize, okay? On the top, my shorter side is 9. On the bottom, my shorter side is 12. I can reduce those by 3, and I get 3 over 4. All right, again, same triangles, but now I'm going to go longer sides. So on the top, the longer side was 18, and on the bottom triangle, my longer side was 24. And I could reduce those by 6, and I get 3 over 4. I get the same ratio for both, which means my side lengths are proportional. And the nice thing is, when I look at those sides, is they are on either side of my angles. So I'm looking at the 2 sets of sides and the angles between them, and they are going to make it by side, angle, side. Okay, I'm trying to figure out what went in that blank. The included angles are congruent because they are vertical angles. We said it, but I didn't write it down. Okay. All right, last one here. Explain how to show these 2 triangles are similar. So I can start by saying, do I know anything about angles? And there is nothing marked on any of the angles. There's no vertical angles. I don't have any parallel lines for angles. So it looks like I'm out of luck for angles, which means I have kind of one choice, okay? I have side, side, side. So let me do some work for side, side, side. That's what I'm hoping for, and we'll see from there. Okay, so you know what might be easier just a bit is I'm going to pull these 2 triangles apart just so you can see them. Okay, so this is 32, 16, 28, which also means this one is 28 because they share that side, 56 and 49. Okay, so it's two triangles, but they're kind of pushed together and they share that one side. So I'm going to put, just to keep myself organized, JKL on top and LKM on the bottom. I have no idea if I wrote those names in the good order, so, I might have, because I guess it matches that. Okay, I'm going to start off shortest sides. So the shortest side on JKL on the left is 28. The shortest side on LKM on the right is 16. Yep. I can reduce both by 4, and I get 7 over 4. Okay, let's go longest side. So the longest side on JKL is 56, and the longest side on LKM is 32. Maybe divide by 8, and I get 7 over 4. So far, so good. All right, my remaining side, right? The remaining side on the left is 49, and the remaining side on the right over there is 28. Let's divide those by 7, and I get 7 over 4. Okay, this is the math I need to prove that my triangles are similar by side, side, side. So I'm going to say yes by side, side, side. Okay, but I have to show that math, and it has to be shown 3 times to do side, side, side. Okay, so I want you to practice from the book, page 391 to 393, 3 through 23 all. You're not going to find yourself with proofs, but you're going to find yourself showing those ratios over and over. I need to see the work. I want to see them reduced. I want you to tell me how you know if those triangles are similar or not. Please let me know if you have any questions.